So I have x squared minus 2x plus 1. So a is 1, b is -2, c is 1. Now, even before I start, I'm going to calculate the discriminant so I can verify the answer at the very end. So b squared minus 4ac is -2 squared minus 4. A is 1. And c is 1. So 4 minus 4. And I get b squared minus 4ac to be 0. That tells us the roots that we're going to get better be repeating. In other words, we will just get one answer. Let's see if we do. So I'm going to plug the values in the quadratic formula. So minus b plus or minus square root of b squared minus 4ac divided by 2a. So minus of minus 2 plus or minus square root of minus 2 squared minus 4 times 1 times c divided by 2 times 1. Minus times minus 2 plus 2 plus or minus square root of minus 2 squared is 4 minus 4ac, I'll get minus 4 divided by 2a, 2. So 2 plus or minus square root of 0. Now we already knew this value. I could have just plugged it in, but I wanted to demonstrate that the b squared minus 4ac is what's going to come into the root. So I have 2 plus or minus 0 over 2. So 2 over 2, I get 1. So there is only one solution, and this is the case we call as a real repeating root, because we need to have two roots. So two roots that are repeating, or I can say that are identical. Okay, now, is there a different way to approach this problem? I could have done this problem with factoring. So x squared minus 2x plus 1 equals 0. If I factor, I can write the negative 2x as minus x minus x. I have x in common in the first two terms. If I pull that out from x squared, I have x. From negative x, I have negative 1. If I pull negative 1 out, I have x minus 1 equals 0. I have a common factor of x minus 1. If I pull that out, I will have x minus 1 equals 0. We have two factors, and we can set each factor equal to 0. X minus 1 equal to 0. The other one is the same. So x is equal to 1, x is equal to 1. And that's what we mean by real identical roots. The reason why we have two roots is because we have two factors, but they are identical factors. So in this problem, one might ask, well, should I use factoring? Should I use quadratic formula? I would go for factoring in this problem. And not only that, this is a special product or special identity case. It's just a minus b squared. So I would just use the identity or go with factoring. So here we have x squared plus 5x plus 1 equals 0. So a is 1, b is 5, c is 1. I'm going to evaluate the discriminant first, so I sort of will have confidence in my solution. So b squared is 5 squared minus 4 times a is 1, c is 1. So 25 minus 4. I get 21, which is definitely greater than 0. So I am going to get real distinct roots. So the quadratic formula is minus b plus or minus square root of b squared minus 4ac divided by 2a. So minus 5 plus or minus square root of 5 squared minus 4ac. We already have that over here. So 21 divided by 2. There is nothing we can do about 21, so we will just leave it as is. So the two roots are minus 5 plus root 21 over 2, minus 5 minus root 21 over 2. So mind you, you cannot factor the given equation. So the only two ways to do this problem is either completing the square or using the quadratic formula. Given the two options, I will just jump right into the quadratic formula. So here we have a to be 1, b is 3, and c is 13. I'm going to do b squared minus 4ac even before I start the problem. B squared minus 4ac is the discriminant, and it is going to give us information about the type of roots that we will get. So b squared is 3 squared minus 4 times 1 times 13. 3 squared is 9. 13 times 4 is 52. 9 minus 52 is 43. So negative 43, I mean. Clearly, this is less than 0. Since the discriminant is less than 0, we are going to get complex roots, and both of them have to be complex because they are conjugates of each other. X would be equal to minus b plus or minus square root of b squared minus 4ac divided by 2a minus 3 plus or minus square root of b squared minus 4ac is minus 43 divided by 2 times a, which is 1. So minus 3 plus or minus 43 is prime. Square root of negative 1 is I. So I root 43 divided by 2. So the solutions are minus 3 plus or minus I root 43 divided by 2. And mentioned the roots are conjugates. So we know what conjugates are, specifically complex conjugates. If one of them has a plus between the real and imaginary parts, the other one will have a minus. So the plus or minus is going to make our complex solution complex conjugates of each other. So this is a case where we have A to be 3, and it is not equal to 1. Now, in terms of completing the square, we would have had to do some extra work, such as dividing by 3 on both sides, making sure I have the coefficient as 1, then proceed with completing the square. But now, since we have the quadratic formula, I'm going to jump right into computing the linear discriminant. So b squared minus 4ac is minus 1 squared minus 4 times 3 times 1. Minus 1 squared is 1. I'll have minus 12. 1 minus 12 is minus 11. So we can go back to our quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. The discriminant b squared minus 4ac is less than 0, so the solution has to be complex. So in a multiple choice problem, may be homework or exam or whatever you may do, if you have multiple options, you don't have to do the entire formula. You just do the discriminant and make a decision as to what the roots would look like, and you can do the process of elimination. So minus b would be minus of minus 1 square root of b squared, which b squared minus 4ac. I have computed that to be negative 11 divided by 2 times 3. So minus of minus 1 plus 1. 11 is prime, and we have a negative. So I root 11 divided by 2 times 3 is 6. So this is a quadratic equation, which is just expressed in a different manner. Keep in mind, the right side of the quadratic equation has to be 0 if we have to solve using the quadratic formula. Currently, the right side is not 0, so x squared, x squared minus 5x. If I move the 3x and negative 1 to the other side, I would end up getting negative 3x, positive 1 equals 0. So x squared minus 8x plus 1 equals 0. And this is exactly the same problem that we did earlier when we were completing the square. It's here somewhere. Right here. So x squared minus 8x plus 1. The solution was 4 plus or minus square root of 15. So it is the exact same problem, but we are going to do it with the quadratic formula. So the discriminant is b squared minus 4ac equals b squared negative 8 squared minus 4 times a is 1, c is 1, so we will have 64 minus 4, we get 60. So the roots are minus b plus or minus square root of b squared minus 4ac divided by 2a. So minus b, so minus of minus 8 plus or minus square root of b squared would be negative 8 squared minus 4ac would be 4, but we found the discriminant part already, and that is 60 divided by 2 times a in this case is 1. So we will have 8 plus or minus square root of 60 divided by 2. I can pull a 4 out of the 60. In other words, I can split 60 as square root of 4 times square root of 15. So 8 plus or minus square root of 4 is 2, square root of 15 divided by 2. So x would equal to, we have a 2 here, there, and there. So we can divide 8 by 2 and 2 root 15 by 2. We can do that in this problem because I can rewrite the expression as 8 over 2 plus or minus 2 root 15 over 2, because we have a common denominator. So the 2 and the 4 will get cancelled. The 2 and the 2 will get cancelled. So I'm left with 4 plus or minus square root of 15. So we have x minus 7 squared equals 4x. Now this problem has a perfect square on one side, but it doesn't have a number on the other side. Rather, it has 4x on the other side. So we cannot use completing the square or the square root property. Not possible. But we can FOIL the left-hand side out and then solve. Now I'm writing it as not possible because, you know, the moment you introduce the square root on both sides, you will have a root on the right-hand side. Then you have to deal with root x. Now that would present a lot of problems, or present a lot of problems, which is why I wrote that those two are not possible. So the left-hand side I can FOIL. So x squared minus 14x plus 49 is what I will get when I FOIL. I can move the 4x to one side, have negative 4x. So x squared minus 18x plus 49 equals 0. Now I have a to be 1, b to be negative 18, and c as 49. B squared minus 4ac is negative 18 squared minus 4 times 1 times 49. 18 squared with a negative, negative's going to go away, is 324. And 4 times 49 is 196. So if we subtract, we will get 128, not 18. This should work, yes. And that is definitely bigger than 0. So we are going to get real roots that are distinct. So x would equal minus b plus or minus square root of b squared minus 4ac divided by 2a minus of minus 18 plus or minus, we already have b squared minus 4ac, which is 128, divided by 2a, so 2 times 1, minus of minus 18 plus 18, square root of 28, I can write it as square root of 64 times 2. Which furthermore can be written as square root of 64 times square root of 2 over 2. Square root of 64 is just 8. So I end up having 18 plus or minus 8 root 2 over 2. So 18 over 2 plus or minus 8 root 2 over 2. The 2 and the 18 will get cancelled. The 2 and the 8 will get cancelled. So we would have 9 plus or minus 4 root 2 as the solution.